Section 2.8, Equations and Inequalities Involving the Absolute Value Function. Make sure to read the learning objectives. To solve equations involving absolute values, you're going to split it up into two rules, which are those two, so make sure you read it. Inequalities involving absolute value will require you to pay attention if it's a less than or a greater than. Less thans are split up into one giant compound inequality, and greater than are separated into two inequalities. Let's start. Problem 1a. The absolute value of 4x equals 20. We first start by splitting up the 4x into two equations, one saying 4x equals 20, the other one saying 4x equals negative 20. To solve, we divide both sides by 4. So the first one gives us x equals 5, and the second one gives us x equals negative 5. Our solution set ends up being negative 5, 5. Problem B. The absolute value of x plus 1 equals 6. Same idea. Split up the x plus 1 into two equations. So x plus 1 equals 6, and x plus 1 equals negative 6. To solve this one, we subtract by 1. We get x equals 5, and x equals negative 7. Our solution set ends up being negative 7, 5. Let's move on to problem C. Problem C is a little bit trickier. Let me move it over a little. It doesn't seem tricky, but it does say the absolute value of 3x is equal to negative 6. The part that's tricky is the negative part. Please remember, absolute values, no matter what you plug into it, always ends up being a positive. Here, they're asking you to take an absolute value, which is a positive, and make it equal to a negative. Absolute values are always positive, so it can never be a negative. Therefore, this one has no solution. That's it for equations, so let's go to inequalities. Problem 2, Part A. Absolute value of 6x is greater than or equal to 18. So we'll split this into two separate inequalities because it's the greater than rule. So we take our 6x, first set it greater than or equal to 18, and then the 6x will be less than or equal to negative 18. We solve by dividing by 6, so x is greater than or equal to 3, or the other one, x is less than or equal to negative 3. These do need to be written in interval notation, so x is less than negative 3, less than or equal to negative 3 first. It goes from negative infinity to negative 3 with a bracket, union, and then 3 with a bracket to infinity. Moving on to B. We have the absolute value of x minus 3 is less than 5. Because this is a less than, when you set it up, it ends up being a compound inequality. So the x minus 3 is inside the compound inequality. One side will be the negative 5, and the other side would be positive 5. To solve the compound inequality, you're still solving for x, but you'll be adding 3 to not just the middle, but to the left side and the right side, because you have to do that to all the sides. So you end up with negative 2 is less than x is less than 8. In interval notation, that just goes from negative 2 to 8, both with parentheses. Problem C. We have the absolute value of x plus 1 minus 7 is greater than negative 9. To solve this one, we will first have to isolate the absolute value. We will do that by adding the 7. This gives us the absolute value of x plus 1 is greater than negative 2. Remember previously I did say that all absolute values are positive. Things that you need to know is that a positive is always going to be greater than negative 2. So in this case, we get all real numbers as our solution. All real numbers in interval notation is negative infinity to positive infinity. Let's move on to part D. Part D says the absolute value of x minus 6 plus 5 is less than or equal to 1. Same idea. Isolate your absolute value. We can do this one by subtracting 5. We end up with the absolute value of x minus 6 is less than or equal to negative 4. Same thing with part C. It's an absolute value. Absolute values are always positive. But in this case, they're telling you that your positive has to be less than a negative. Positives are never less than a negative. So this inequality has no solution. Let's look at part E. It's the absolute value of 2x minus 7 minus 3 is greater than 12. We'll start the same way. Isolate. To isolate, we will add 3. We get the absolute value of 2x minus 7 is greater than 15. This one, we actually have to do a little bit of work. We set it up, so 2x minus 7 will be greater than 15. And the second one will say 2x minus 7 is less than negative 15, with the word or in the middle. We will solve, so add 7 to both sides. We get 2x is greater than 22. Then we divide the 2, so x is greater than 11. On the other one, we still add these 7, but this time we get 2x is less than negative 8. Divide by 2, we get x is less than negative 4. So as an inequality with this OR statement, we end up with negative infinity to negative 4 with a parentheses, union 11 to infinity. So that's problem E. Our last one is problem F. Problem F says 4 minus the absolute value of 3x plus 5 is greater than or equal to negative 7. I will first isolate. So to remove the 4, we actually subtract the 4. This gives us a negative absolute value of 3x plus 5 is greater than or equal to negative 11. We need to remove the negative now. To do that, you're going to divide by negative 1. This gives us the absolute value of 3x plus 5 is less than or equal to, because we divided by a negative, 11. This is your compound inequality because it's a less than. So we set the 3x plus 5 inside a compound inequality with the two less than signs. On the left side will be negative 11. On the right side will be positive 11. So to solve, we subtract 5, but remember you have to subtract it to the left and the right as well. We end up with negative 16 is less than or equal to 3x is less than or equal to 6. We divide the 3, again to the left and the right as well. That gives us negative 16 thirds is less than or equal to x is less than or equal to 2. As an interval notation, the answer ends up being bracket negative 16 over 3, comma 2 with a bracket. And that's our lesson.